So in this video, as you may notice here, we have the appetizer problems. We're still in the lesson objective 9 and 12C. So we're getting to the part where we're going to be solving a log equation. But before we actually are able to solve log equations, we really need to make sure we can see these log expressions and be able to simplify the log expressions using the properties of logs. So we can see the properties of logs over here on the right-hand side underneath the picture of the appetizers. And these are the building blocks like we talked about. But let's go ahead and do a couple examples. So if you have to simplify a log expression, many times you see multiple log expressions on the same side, let's say of an equal sign. Like let's say this is log of ... whatever. Well, before you solve equations, you have to be able to gather all the log expressions into one and to rewrite that, those multiple log expressions into one expression. And as we see, we have the quotient rule. So if we look right here, we have the difference of the logs. So the difference of the logs, we're going to write that as the log of the quotient. So that's equal to the log of, actually I shouldn't write it over there. Let me write it down here. That's equal to the log of 16 divided by 2. And so we're going to write that as the log of 16 divided by 2 is 8. And so that's it. It's as simple as that. Just use the property of logs to rewrite log expressions down to one log of a number. And that's what this says here. It says rewrite each expression, which we did, as the log of some number. That's just right there is some number. So we have the log, doesn't matter what the base is, and it's some number. That's what we did, log of some number. So let's do another one. We have, let's say, 4 times the log of 2. And right now we have this number out in front of the log, and we don't want to leave it out there. We have to rewrite this as log of something. And so when we rewrite the expression as log of something, log of some number, what's going to go there? Well, we use the properties of logs. So look over here, we have the power rule. So we have a times the log of x equals log of x to the a. So we're going to go ahead and rewrite this as log of 2 to the, and we're going to just think we get to just kind of move that 4, that number out in front, to the exponent position, and that's exactly what we get to do. So 4 times the log of 2 is equal to log of 2 to the 4th. And we know that 2 to the 4th is 16. So 4 times the log of 2 is equal to the log of 16. That's it. And now two more examples. Maybe pause the video and see if you can complete these examples before I do them. And then just check your solutions. So we're going to take log of 5 plus the log of 6. Let's make it interesting. Let's make it the log base 3 of 5 plus the log base 3 of 6. So you can see it doesn't just work for base 10s. Now again, you can either pause the video or just think to yourself, what am I going to write? Well, we're going to use the product rule right here because we have the sum of the logs. This is the sum of the logs, And when we have the sum of the logs, we write that as the log of the product. So log base 3, the base doesn't change anything. It just comes along for the ride. Log base 3 of, now 5 times 6 is 30. And many times in the beginning, students forget that that's just an exponent you have to raise 3 to get to 30. So you wouldn't want to write 10 right there. I get that a lot. Students in the very beginning of this unit, they think log base 3 of 30 is 10, but no, it's not. It's the exponent you have to raise 3 to get to 30. And we did that early on. This maybe you could estimate that right now before we go on to the next example. But 3 raised to the 3rd power is 27. 3 raised to the 4th is 81. So this log base 3 of 30 would be a little bit more than 3, or a number between 3 and 4. And finally, We're going to simplify this. 2 times the log base 5 of 3 plus the log base 5 of 4. Now this particular problem has 2 steps. First thing we're going to do is we're going to move any of the coefficients to the exponent position. So we're going to write log base 5 of 3 to the second power using the power rule. And then in our next step, we're going to combine. We have the sum of the logs, and we're going to write that as the log of the product. So we have the log base 5 of 3 squared times 4. And so all I did was I used the power rule first, and then I used the product rule. And then we can simplify this. That's the log base 5. Now, of 3 squared is 9, and 9 times 4 is 36. So we have rewritten the initial log expression as a log with a base of a number. So log base 5 of 36. And that's it for this video. That's it for the appetizers.